Welcome to Wildcat Science with Mrs. Haugo. This is Chapter 7, Part 8 on the skeletal system. And we are talking about what movement joints can do. So first off, let's start with flexion, which is a bending a joint that decreases the angle between the two bones. So flexion at the elbow joint will decrease the angle between the humerus and the ulna. And then looking at the skeleton, flexion at the knee joint will decrease the angle between the humerus and the tibia. Extension would be the opposite, straightening at the joint that increases the angle between the two bones. So then straightening would increase the angle between the upper and lower arm bones. And then at the knee joint, extension would straighten and increase the angle between the humerus and the tibia. And then hyperextension is beyond the anatomical position. So for example, if flexion at the neck looks like this, then extension would be straightening and increasing the angle of the neck, and then hyperextension would be beyond the anatomical position. Another term is abduction with a B, and that means movement away from the midline. So you could abduct the arm. You could also abduct the leg. Adduction is the opposite. It is movement toward the midline. So you could adduct the arm. Likewise, you could adduct the leg back down. Rotation is another term, and it is twisting the bone on the axis. So if we think about our arms, and then the radius and ulna can twist. If you see, I'm twisting it along the axis if you were to make an up and down axis. And you can do that yourself and see it even better. And then another one is circumduction, which combines movements to make a circle. So your shoulder joint can circumduct, and also the hip joint can do that also. Okay, we're going to go over some more movement words. You don't have to write them down, but we will be covering them more later. So there is protraction, which is move forward, and then the opposite of that would be retraction, which is moving a joint backward. Then elevation, which is to raise, and then the opposite of that would be depression, which is to lower. So to raise the shoulder joint, the pectoral girdle, and to lower, elevate, depress. So there are some special terms just for your forearm and lower leg because they can do some things the rest of your body can't. Supination is when you turn the palms up, like you're going to carry some soup. And then pronation is turning the palms down. And then for the foot, eversion is moving the sole of the foot laterally outside, and the opposite is inversion, moving the sole medially or inside. And then also special terms for the foot, dorsiflexion means you raise the foot, raise the toes, and plantar flexion means to point the toes, point the foot. Okay, so let's take a look at the movements for the lower leg. There is eversion, which is moving the sole of the foot laterally, and inversion, which is moving the sole of the foot medially. A common sprain is an inversion sprain, where you roll your ankle. And then dorsiflexion, where you raise the foot, and then plantar flexion, where you lower the foot or point the foot. Okay, looking at some more pictures of joint movement, we can have flexion, extension, and hyperextension of the wrist joint, and then flexion and extension of the knee joint, abduction and adduction of the hip joint, and then dorsiflexion and plantar flexion of the ankle joint. Okay, looking at pictures of more joint movements, we can have rotation at the shoulder joint, and we can have circumduction at the shoulder joint, and supination and pronation at of the hands. And more pictures, we can have protraction, retraction at the neck, and elevation and depression of the pectoral girdle, and then you can have inversion and eversion of the ankle joint. Okay, now we're going to talk about the different types of synovial joints and then how they allow us to do the movements we just learned. We're going to start out with the ball and socket joint. It consists of a ball-shaped head articulating with the cup-shaped cavity. It allows a wide range of motion. 3 directions are possible, and this is circumduction. One example is the hip joint, which allows circumduction of the leg. Looking here, the leg can do circle, and also the shoulder joint, where you can do your circumduction. And looking here is a picture of the ball-shaped head fitting into a cup-shaped cavity, so the ball-shaped head of the femur fitting into the acetabulum of the pelvic bone. A second type of joint is called a saddle joint, and this is where one bone fits into a saddle-like depression of another bone. This also allows a wide range of movement, not quite as much as the ball and socket, but still quite a bit. It can move in 3 directions: flexion, extension, abduction, adduction, and rotation. And an example is the trapezium, which is a carpal, and the thumb. So if we look at the proximal phalanx of the thumb, and there is a saddle-like joint between the trapezium and the phalanx. Getting a close view, we can see that one saddle-like bone fits into the depression of another, right here with the the metacarpal of the thumb fits into the saddle of the carpal, the trapezius. And that allows quite a bit. Our thumbs, that allows them to do a lot more than just our fingers. It allows flexion, extension, abduction, adduction, and rotation. And it allows those opposable thumbs that help humans so much. The third type of synovial joint is the condyloid joint, and this consists of an egg-shaped condyle fitting into a rounded cavity. And this allows a variety of motions. Still quite a bit of motion, not as much as the first 2, ball and socket and saddle joint. So 2 directions, flexion and extension, and abduction and adduction. A good example is between the metacarpals and the phalanges. So between the metacarpal and the phalanges, because you can do flexion, extension, abduction, and adduction. Looking at the picture up close, you can see that there is a cup-shaped condyle fitting into a rounded cavity, and it allows movement in those 2 directions. A fourth type of synovial joint is the pivot joint. This consists of a cylindrical surface which rotates within a ring of bone and fibrous tissue. And the movement that it allows is rotation. Two examples are the atlas and axis, which allows rotation of the head, and the radius and ulna, which allows rotation of the lower arm. So looking at the picture, we see there is a cylindrical surface which rotates within a ring of bone and then also fibrous tissue. And you'll have a chance to look more closely at the skeleton in class. In the fifth type of synovial joint, we're going to talk about the hinge joint. This is where a convex bone fits into a concave bone. And this allows motion in one direction, flexion and extension. One example is at the elbow. It allows extension and flexion. And we talked quite a bit about how the processes and fossas fit together in the elbow joint. And we'll take a look more at the skeleton in class. Another example is the knee, where there is, at the knee joint, it allows extension and flexion. And that is where you have a convex bone fitting into a concave bone. This also happens between the phalanx bones in the fingers and toes. So not between the metacarpal and the phalanx, but between the two phalanx. So it allows flexion and extension. Flexion and extension. And here is an example of a convex bone fitting in a concave bone for a hinge joint. Okay, the sixth and final type of synovial joint is the gliding joint. And this consists of nearly flat or slightly curved surfaces. And it allows limited back and forth motion. And this is the most limited motion of the synovial joints. So some examples are the joints among the carpals in the wrist and the joints among the tarsals in the ankle. As you can see, a lot of these bones have flat or nearly flat or slightly curved surfaces. And so when you are moving your wrist, those bones, those 8 little bones, are kind of sliding past each other right in here. So again, you can see, like if you were moving your wrist, those little bones can slide past each other just a little bit. And then the same thing is happening in your foot. As you can see in your foot, there's a little bit of back and forth motion among the tarsal bones as your foot moves. Okay, we're going to go over some more pictures of the different types of joints and some examples. So we're going to start with the least movable joint, the gliding joint. You can see it has some little back and forth motions, just a little bit on the flat surfaces. Example is the acromioclavicular, which is between the acromion process of the scapula and between the clavicle. And there's a little bit of movement between those 2 points, and we'll look at that more closely in class. And the sternoclavicular joint, which there's a little bit of movement between your sternum and your clavicle when you move your shoulder around. And then we already talked about intercarpal and intertarsal joints, the joints between the carpals and between the tarsals. And then vertebrocostal joints and sacroiliac joints, so between the sacrum and the ilium. And then the hinge joint has more movement. It has movement in one direction, flexion and extension, like the elbow, knees, the ankle joint. So if you look between the tibia and the talus, that allows flexion and extension. And we already talked about the in between the phalanges. And then the pivot joint allows rotation. We talked about the atlas and axis and about the radius and ulna. We're going to pause there. We're going to review the last 3 types of joints in our next video, and we're going to talk about disorders, what could possibly go wrong. Okay, see you then. Bye.